Okay, this video is going over the 9 problems we did on area on January 8th, Tuesday, January 8th. So when we first write, so we have 3 figures, 3 areas of 3 different shapes. So we have the area of a circle. So, the wrong pen. We have area of circles, areas of triangles, and rectangles. So the area of a circle. Okay, area of a circle is going to be pi r squared. Okay, the area of a rectangle is the length times the width. And then the area of the triangle is going to be 1/2 the base times the height. So you guys should have that written on your half sheet on the back of the polygons notes. So on the back, we should have the 3 area formulas written down. Okay, what we're going to do is follow a process to find the area of these shapes, these figures, using the area of circles, rectangles, and triangles. So the process we're going to use, step 1, is going to be identify the components. Okay, for example, in number 1, we can break figure 1 here into a triangle and a rectangle. Step 2 is to find the areas. Find the area of each component. Then step 3, we're either going to add or subtract, addition or subtraction, depending on the scenario. Okay. So we have 3-step process, and we're going to use 3 different area formulas, one for circle, rectangle, and triangle. So number 1, as we just said, the first step is to identify the components. So if we're looking for components, we have a triangle. So I'm going to draw it separately so we can really see what we're looking at. We have a triangle. We have a rectangle. The dimensions of the rectangle are 7 by 14. Since this is a rectangle, we know opposite sides of rectangles are the same length. So we know this side is also going to be 14. So that means the base of our triangle is 14. We know this length right here is going to be 7 as well. So if the whole thing is 14 and this piece is 7, then this upper piece is also going to be 7, right? 14 is the whole thing. Okay, so 14 minus 7 is going to give us 7. So we know the height of our triangle is 7. Okay, right? So step 1 was to identify the components, the rectangle and the triangle. We've done that and we found the dimensions. Okay. Step 2 is we want to find the area of the components. Okay, so the first one is a triangle. So the area of a triangle is going to equal 1/2 the base times the height. Well, we've already found the base and the height. The base is 14. The height is 7. 1/2 times 14 is 7. 7 times 7 is 49. Now we have to find the area of the second component. So this is a rectangle, so the area of a rectangle is length times width. The length is 14, the width is 7, or you could say it the other way, the length is 7 and the width is 14. So 7 times 14 is going to be 98. So if we erase all this, well, keep our line here. The area of the rectangle is 98. The area of the triangle is 49. So what's the area of the whole thing? The area of the whole thing is going to be 98 plus 49, which is going to give us 147. So the area of figure 1 is 147. Number 2, step 1, we want to identify the component. So we have a circle or half of a circle. So this is half of a circle. And we also have a rectangle, specifically a square, but we know squares are rectangles. All squares are rectangles. So we just use the rectangular formula. Okay, the dimensions of our rectangle are 18 by 18. And we know the radius of our circle is 9. So let's start with the area of the rectangle. We know the area of a rectangle is length times width. So area is going to equal length times the width. So it's going to be 18 times 18, which is going to be 324, I believe. 18. Just want to make sure. I mean, I knew it was. We'll just double check. 324. Now, if we wanted to find the area of the whole circle, the area of a circle is pi r squared. Okay, but we want to find half of a circle, right? We don't care about the area down here because that's already accounted for. Right, here's the full circle. All of this is already accounted for in the area of the rectangle. So we're not looking for the area of the whole circle. We're looking for the area of half of a circle. So we can either divide our answer by 2 at the end, or we can stick in a half here. Half of pi r squared. I think it's better to do it this way. Conceptually, we're taking half of the area of a circle, as opposed to finding the area of a circle and dividing by 2. So I like doing it this way better. I think it's more thorough. The problem with it is, don't confuse yourself on the area of a circle. The area of a circle is pi r squared. It's not 1/2 pi r squared, it's pi r squared. Okay, so I'm a little bit worried doing it this way that some people are going to think the area of a circle is 1/2 pi r squared when it's not. They'll confuse it with the area of a triangle, which is 1/2 the base times the height. Because a triangle is sort of like being half of a rectangle. But yeah, just don't get confused. Okay, so we have area is 1/2 pi times 9 squared. Okay, and we can just plug that in our calculators. It's going to end up being 81/2 times pi. So let me put that in. I don't remember the exact answer. I think it was like 157 or something like that. Or 127. 127. Okay, you can put approximately 127, or you can put the exact answer, which here is 127.235. But you can round if you want. If you want to round to the nearest whole number, that's fine. No big deal. So the area of the rectangle is 324. The area of the half circle is about 127. So approximately the area of the whole thing, we have to add them together. 127 plus 324 is going to give us 451. Approximately 451. Not exactly. It's really 451.235, but we can estimate, or not estimate, we can approximate if we'd like. Okay. So that's number 2. Number 3 is very similar. So we can, step 1, we want to break the figure into component parts. So in this one, we can break it into a rectangle and a circle, just like in number 2, or a half circle. So the half circle here, I have a radius of 6, so the area is going to again be half pi r squared because it's half of the circle, so it's half of the area of the circle. And the radius is 6, so here we have 36. Divided by 2 is 18, so it's going to be 18 pi. Okay, you can just put this all in your calculator from here. But it's going to end up being 18 pi, which is going to be approximately 56.5. Okay, so it's about 56.5. Then we can do the area of the rectangle. The dimensions are 15 by 20. So our area is going to be length times width. So it's going to be 15 times 20, which is going to be 300. Right, so step 1, identify what we have. We have a semicircle, a half circle, and a rectangle. Step 2 is find the area. So we find the area of the half circle by taking half the area of what the circle, full circle would be. And then we find the area of the rectangle to be 300. So 356.5. To find the total area, we're going to add them together. So 300 plus 56.5 gives us 356.5. It really should be yards squared, centimeters squared, inches squared, but we're not going to worry about units, again, for our purposes. Next set of problems we did in class. Right, so number 4, we can break it up into a triangle and a half circle. The half circle has a radius of 8. The triangle has a height of 12, and it's going to end up having a base of 16. Some students struggled with where we got the 16 from. Let me try to give it my best explanation. So we have a circle. So if I were to draw the circle in, it would look something like this. Not perfectly like that, but something like that. We know the radius of this circle is 8. So it doesn't matter where the radius is, right? If we have a point at the center and any point on the circle, right? That's how we define a radius. It goes from the center to one of the points on the circle. That's what a radius is. So if we go from the center to here, that's going to be 8. If we go from the center to here, right, it's also going to be 8. And if we do it in a way such that we have right angles here, we know we have a straight line. Okay, so if the radius, I didn't draw it very straight, but it should be straight. Okay, so it's like the diameter. Right, you put a triangle in here. Right, well, if this piece is 8 and that piece is 8, what's the whole base? The whole base is going to be 16. This is a radius. Radius of the circle is 8, right? So everything around here would be a distance of 8. So 8. Base is 16. Okay. So once we have that established, we can find the area of each piece. So the area of the triangle is going to be equal to the base, 1/2 the base times the height. So we have 1/2. The base we said was 16. The height is 12. 1/2 of 16 is 8. 8 times 12 is 96. Okay. Semicircle, again, it's half of a circle. So the area of a circle is pi r squared. But we only have half a circle, so it's going to be 1/2 pi r squared. So we have 1/2 pi. The radius is 8. 8 squared is 64. 64 times a half is 32. So we're going to end up with 32 pi, which is going to be approximately 100 and 100.5, we'll say. I think, right? 32. If I remember correctly, 32 pi is 100.5. 100.531, so about 100.5. So if we want to find the area of the whole thing, the area of the half circle is 100.5. The area of the top of the triangle is 96. So the total area is 100.5 plus 96, which is going to be 196.5. If you want to round the whole number, that's fine. If you want to have it 197, I'm okay with that too. Okay, number 5, we're breaking it into two rectangles. So the first one is 12 by 12. The second rectangle is 20 by 12. Okay. So the area of a rectangle is length times width. So we have 12, length of 12 and a width of 12. So our area is going to be 144. Okay. Second rectangle also is going to equal length times width. So it's going to be 20 by 12. 20 times 12, I believe, is 240. 20 times 10 is 200. 2 times 20 is 40. 200 plus 40 is 240. So our area here is 240. So the area here is 240. The area of the top rectangle is 144. So what is the area of the whole thing? The area of the whole thing is the area of these two rectangles added together. So 144 plus 240 is going to give us 348. 348. Okay. The last one. Okay, step 1 is to break it into components. So what two figures can we divide it into? Break it down into? Well, we make it into a square, or I'm sorry, a rectangle and a triangle. But it's going to end up being a square. A square is a rectangle. So we have our rectangle, which is also a square, which is 20 by 20. And then we have a triangle, okay, which is going to have a height of 10, right? It's telling us the height is 10. Okay, so if we put a dotted line in here, we know that dotted line would be 10. And this piece right here is going to be 20. Why is it 20? It's because we have a square. So all the sides are 20. So we 20, and then we have a height of 10 as indicated. So the area of the rectangle is going to equal length times width. So 20 by 20, which gives us 400. The area of a triangle is 1/2 the base times the height. Okay, so it's going to be 1/2. The base is 20. The height is 10. 1/2 times 20 is 10. 10 times 10 is 100. So the area here is 100. So if we erase this part, the area of the rectangle is 400, and the area of the triangle is 100. Okay, so the total area, we have to add them together. 400 plus 100 gives us 500 centimeters squared. For our purposes, we're not going to worry about units. It's just just 500. Maybe we should be doing units, but it's too late to change. We should be doing units, but it's too late to go back, I think. All right. Well, it's never too late. Maybe I'll start using units. I just don't want to confuse anybody at this point. But 6 of the problems we did, the last 3 had to do with subtraction instead of addition. So it's the same process, except right, we're going to identify the components, then we're going to find the area of the components. But instead of adding, we're going to subtract. So again, we can look at 2 different figures here. We have a triangle with a base of 20 and a height of 20. And then we have a rectangle, right? This rectangle right here, which is going to be 5 by 15 centimeters. How do we find the area of a triangle? Well, it's 1/2 the base times the height. So we have 1/2 20 times 20. 1/2 of 20 is 10. 10 times 20 is 200. Then we have the area of a rectangle, which is length times width. So we have 5 times 15, which is going to give us 75. So we know the area of the triangle, so the area of the whole thing is 200. Okay. If we're asked to find the shaded region and the unshaded region, let's start with the unshaded. The unshaded part is just simply this rectangle, and we know the area of this rectangle is 75. So the unshaded is 75. Centimeters squared. So we know the whole triangle, if I draw it out, the whole triangle is 200. But if we remove a piece that is 75, we have to subtract that 75 from our 200, and we get 125. So the area of the whole triangle is 200. Okay, but if we only want the area of the shaded region of the triangle, we have to subtract the unshaded area. So the unshaded area is part of the whole triangle. Since it's part of the whole triangle, we need to subtract it from the whole triangle to get the shade, the area of the whole triangle to get the shaded region, the area of the shaded region. So this is the area of the shaded and the area of the unshaded. Number 2. Number 2, we have 2 circles and a rectangle are our components. So let's start with the rectangle. A rectangle is 43 meters by 30 meters. So the area of a rectangle is length times width. So that's 43 times 30. And 43 times 30 is 40 times 30 is 1200. 3 times 30 is 90, so it's going to be 1290. Let's just double check on the calculator to be certain that I'm not being an idiot. $12.90. And then we have an area of a circle with a radius of 10. So the area of a circle is pi r squared. So the area is going to be pi times 10 squared. Well, that's going to be 100 pi, which we can approximate as 314. Right, really 314.159, but it's about 314. We also have another circle that's the same size and shape. So we know that area is also going to be about 314. So we have this circle is 314, this circle is 314, and this rectangle is 1290. So if we're asked two questions, if we're asked for the shaded, area of the shaded and area of the unshaded. Let's start with the unshaded region. So there's two components that are unshaded. That's the two circles. So if we want to find the unshaded region, we have to add the areas of those two circles together. 314 plus 314 is going to give us 628. So the unshaded region is 628. If we want to find the area of the shaded region, we have to take the area of the whole thing and subtract the unshaded region. So the area of the whole thing is the rectangle, which is 1290. We need to subtract the unshaded areas, right? Because it's either shaded or unshaded. So if it's not unshaded, it's going to be shaded. So to find the shaded, we have to subtract the unshaded. Okay, so 1290 minus 628. Okay, we could also think of it as minus 314 minus 314. Either way, however you do it, you're going to end up getting 662, which is the area of the shaded region, 662 meters squared. We got one more, right, for what we did in class. There's a whole bunch more problems I have, but I'll just go over the ones we went through in class. So we have a circle and a triangle. So we have a large circle with a radius of 19. Right, it's telling us the radius here is 19. It's an interesting place to put it, but it's telling us we have a radius of 19. So the area of a circle is pi r squared. So we have pi times 19 squared. So if we put that in the calculator, I'm not going to do that in my head. 19 squared is 361, so it's going to be 361 pi, which should put us at about 1,000. 134, approximately 1,134. Again, we're rounding. Right, the second component was a triangle. The unshaded region was a triangle. Okay, that triangle's dimensions are 18 by 35. Okay, so the area of a triangle is 1/2 the base times the height. So the area of the triangle is going to be 1/2. The base is 18. The height is 35. So 1/2 times 18 is 9. 9 times 35. Well, it would be 350 minus 35. Which is 315. So again, if we're asked what is the area of the shaded region and the area of the unshaded region, well, we know the unshaded region is the triangle. So the area of the triangle is 315. So the area of the unshaded region is 315. And to find the area of the shaded region, we have to take the area of the circle, right? So the area of the whole thing, which is 1134, and then we have to subtract away the triangle. So we have to get rid of the triangle. The area of the triangle was 315, so we have to do 1134 minus 315, which is going to give us and then we go down to 11 minus 3 is 830. So 39 and 15 is going to give us 854. 854 plus 300 is 954, 1054, 1154. So we have 839. Or we can put it in the calculator and double check, but I'm satisfied that that's correct. All right, and so those are the 9 problems we did in class on Tuesday, January 8th, to be followed by some more difficult problems on Wednesday, January 9th. Well, they won't be more difficult if you simply follow the process. So we want to identify the components, find the area of each component, and then we have to figure out if we're going to add or subtract according to what the problem's asking for and what we are given.